of time this unit talking about trigonometry. And we learned the other day that trigonometry is the study of measurements in triangles, right? We learned that it's the study of measurements. Now, what kind of things can we measure in a triangle? Angles and sides, right? So the things we measure in a triangle, angles and sides. We have learned previously to find missing sides of a triangle. If you know two sides of a right triangle, you can use Pythagorean theorem to get the third side, right? We also have talked about similarity in triangles. We've talked about special right triangles, 30, 60, 90, and 45, 45, 90, all in this unit. Okay? And then we started using trigonometry, which was a blend of knowing some angle measures and some sides. And what was our acronym to help us remember sine, cosine, and tangent? SOHCAHTOA. They're disappearing. Like as soon as I write it, it's disappearing. What the heck? It's magic. Look, and now here they are on top of each other. That's all right. SOHCAHTOA. Sine is what over what? Opposite over a hypotenuse. Cosine is adjacent side over your hypotenuse. And tangent is opposite from your angle over adjacent to your angle. Okay. So what we're going to do today is basically use sine, cosine, and tangent. But instead of showing us a triangle, they're going to give us an application problem, otherwise known as a word problem. And we're going to have to draw the triangle based on the information they gave us. So we're actually going to have to get a little creative and draw. Okay, if you can get as creative as you want to. You notice on my paper I actually have little pictures right here. Which are hilarious because I can't draw with a flip. Or you can just draw a triangle and label your stuff. Okay? It's probably what I'm going to do because I can't draw. And y'all will laugh at me. But it's okay. Well, yes, you did. Yes, you did. Okay. Jake leaned a ladder against his house. Okay, so picture it. We got a house. Here we go. Look at my house. Woohoo. Okay, let's pretend that we have. Yeah, I know. There's Jake's house. And he leaned a ladder against his house. There's the ladder. So already this ladder is looking like a what? All right, looks like a hypotenuse, doesn't it? That ladder does. Because we're going to hope that his house is perpendicular with the ground. Okay? If the angle formed by the ladder and the ground, well, the ladder meets the ground down here, doesn't it? Okay? It's 68 degrees. So you can label that 68 degrees. And the distance from the bottom of the ladder to the bottom of the house, well, that's this distance right here, isn't it? Is 5 feet. Yeah, sorry. Stop. That is like the Siri for the. What is. Y'all. My pen. It's 5 feet. What is the length of the ladder? So it's look for how long the ladder is. And the ladder is the what of that right triangle? Hypotenuse. So we've got our 68-degree angle down here. What is the 5 feet down here compared to the 68-degree angle? Is that opposite or adjacent? It's adjacent because it's touching that angle. Y'all agree? Why is my pen? Y'all, I don't know if the battery in it's dying or what. It's done it to me a couple times today. All right, so if I have an adjacent and a hypotenuse, am I going to use sine, cosine, or tangent? Cosine. So we're going to say cosine of what's our degree? 68. Y'all. This is on my everlasting nerve. It's not letting me write. Sorry, y'all. I don't know what's doing. this. Equals, it's seriously not writing. Cosine 68 degrees equals, y'all, I'm getting mad. Like, seriously. Hang on, let me try this. If I flip it, it worked. But let's see how long it lets me work with it flipped. Cosine of 68 degrees equals what? Adjacent over hypotenuse. Any questions about how we set up that? Let's just can we call the hypotenuse X instead of H? Whatever variable. If y'all want to leave it H, you can. I'm going to call it X. Okay. So, X is everybody okay with why we're using cosine? If you don't use the right ratio, we're going to get it wrong, unfortunately. So, how do we solve for X if X is in the denominator? Multiply by X to get it out of the denominator. Very good. So, I have X times cosine of 68 degrees equals 5. Now, how do I get X by itself? Divide by the cosine of 68 degrees. So X is going to equal 5 divided by cosine of 68 degrees, right? So how do we get that? Calculator, right? All right, so y'all bear with me for a second while I get my calculator turned on. I hadn't done that yet today. What mode should we make sure we're in? Make sure, before you do anything with trig, make sure you're in degree mode. So I'm going to do that with mine. You click the mode button and make sure degree is highlighted. Y'all's highlighted. How do you go back to the home screen? Second mode. Goes home. All right, so we're typing in what? 5 divided by cosine. Do we hit inverse cosine or just cosine? Regular cosine because we know the angle measure, right? And the angle measure is 68 degrees. And then close parentheses and hit enter. And are we getting about 13.3, everybody? So the hypotenuse, or the length of the ladder, is about 13.3 what? Feet. Now, word problems need words with your answers. So make sure you include units on these because these are application problems. Okay? So I apologize for the delay in trying to get my pen to work. Maybe I can fix it now. If not, I know that worked. Okay. So any questions about number 1? Number 2. A ramp is used to load suitcases onto an airplane. Okay, so the airplane, y'all don't laugh at my drawing. Here it is. Airplane has wings. This is like a bee, doesn't it? Okay. So the airplane is like sitting off the ground, right? Right. So there's actually a height between the airplane and, I'll just put right here, the airplane, and the ground, right? Okay, and then there's a ramp. If y'all can draw good airplanes, you have fun with it. So the airplane, the door to the airplane where they're loading the cargo is off of the ground, and there's a ramp that carries the suitcases up. Okay? It says the ramp is usually suitcases onto an airplane. If the cargo door, that means the door to the airplane, is 7 feet from the ground. So that's this height right here, isn't it? Mm-hmm. And the angle formed by the end of the ramp and the ground, where is that at?
It's down here. Right there.
It'd be right there, wouldn't it? Is 25 degrees. How long is the ramp? So y'all tell me, y'all think we're going to use sine, cosine, or tangent? Sine, why? Yeah, we have the opposite, and the ramp that we're finding is the hypotenuse. So it's important that you draw and label your picture correctly. Does that make sense? Because if I put the 7 down here, I'm going to use cosine. So we got to know that the height of the cargo door is that vertical height right there. So yes, we have opposite and hypotenuse, so we need to use sine of how many degrees? 25 degrees equals opposite over hypotenuse, so what over what? 7 over x. So any questions about how we set up our problem? All right, how do we get x out of the denominator? Multiply by x on both sides. So we have, those cancel, x times the sine of 25 degrees equals, it's doing it again. Now how do I get rid of sine 25? Divided by sine of 25 on both sides. So x equals 7 divided by sine 25. So after you have your x by itself, then you can use your calculator. So 7 divided by sine. Do we use sine or inverse sine? Sine, because we know the angle. I'm trying to hit parentheses. There we go. About 16.6 what? Feet. Yep, and that's the length of the ramp. And that's the hypotenuse. And does that make sense if the hypotenuse is longer than that 7 feet tall? Yeah. Okay, so if you're looking for a hypotenuse, make sure it's longer than the other side that you got. Okay, let's do number 3. Okay. Jaden is flying a kite, and that should be off, right? Typos all in this problem. Let's off 275 feet of string. Okay, so here's Jaden down here. She's got a ponytail. She's flying a kite. Davis flew a kite yesterday. It didn't work out well for him. His string kept getting tangled. Okay. Actually, she should not be spitting out the string. She should be holding it. Okay. Okay. And that's 275 feet for that hypotenuse, right? The kite is 150 feet above the ground. 150 feet from the ground. So we'll say it's perpendicular to the ground then if it's 150 feet from the ground, right? And assuming the string is, it should say string is straight, not the kite is straight. Assuming the string is straight, what angle does the kite make with the ground? So I'm looking for which angle? The angle where Jaden is or the angle up at the top where the kite is? What do y'all think? But this could be an angle with the ground. Now, Jaden and the string is making a different angle with the ground, right? But it said what angle is the kite making with the ground?
So it'd be the top.
So it's going to be the top angle. Does that make sense? Okay, y'all, my pen. So this is we're looking for this, the angle measure. Y'all see that? So that already tells me if we're looking for an angle measure, we're going to have to use what? An inverse function. Very good. So are we going to use sine, cosine, or tangent? Yes, because we're adjacent to our angle, and this is the hypotenuse. Very good. So we're going to say cosine of x equals what over what? 150 over 275. So how do we get x? How do we get the angle measure? X equals what? inverse cosine of that ratio. Y'all with me? Okay, so how do we do inverse cosine in our calculator? Second cosine and then the fraction 150 divided by 275. Hit enter. It's about 56.9. What's our units? 56.9 degrees. If we're looking for an angle measure, it needs to be in degrees. Any questions about that? I want y'all to try example 4. Y'all try that one. You try example 4.
Okay, can we use 0, 0 as a test point here? Yes, we can. All right, so if we can use
Trying to figure out what's going on with the pen. I think the battery's not in.
What's 3 times 0? 0 plus 0. Is 0 greater than or equal to -4? It's greater than, so it does work. So we are stating where 0, 0 is, so that would be above the line. In the order pairs in that shaded region is a solution to this insult. Right, once you're done with this, again, number 7 on your own. Very similar to 5 and 6.
Messaging my tech. Papa Joe is here. It's good for teachers to know a good tech person. Right. Even better than very good. Yeah, so what's important is knowing what you got and knowing where to put it and knowing what you're looking for. Kind of hard when they don't give you the triangle, isn't it? Because you got to make sure you understand the problem and what it's asking you to find and the information they give you, understanding how to put it in the correct place on your picture. Okay, y'all check with each other. All right, so y'all check with me. Okay, a pole is leaning against a wall, right? Well, I'm going to say my wall is perpendicular with the ground. Okay, so there's my wall. And the pole is leaning against the wall. So there's my pole. Did y'all draw something like this? So the pole is the hypotenuse. Y'all see that? Okay. It makes a 75-degree angle with the ground. So where does the pole meet the ground? Up here? or down here?
Down here.
At the bottom. Okay. So that's a 75-degree angle right here. It says if the bottom of the pole is 6 feet from the base of the wall. Where's that at? The bottom of the pole is 6 feet from the base of the wall. Where's that at? Right here. Y'all agree? So that's 6 feet. How high up the wall does the pole reach? So I'm looking for this length. Y'all agree? Sugarfoot. Undo. So I'm looking for this length. Do y'all agree? So do you need to use sine? Here's my angle. Do I need to use sine, cosine, or tangent? Tangent, because I don't know the hypotenuse. I don't know the length of the pole at all, and I don't need it. Y'all agree? So we're going to use tangent. Opposite and adjacent. So tangent of what degree? 75 equals what's opposite from the 75-degree angle? X is opposite, 6 is adjacent. So X over, here it is not working again, over what? 6. All right. So how do we solve for X? Just multiply both sides by 6. So 6 times tangent of 75 degrees equals X. And I've got X by myself, so I can use my calculator. 6 times tangent. Do we use tangent or inverse tangent? Yeah, if you know that angle measure in there, you use regular tangent. Did y'all get about 22.4? 22.4 what? 22.4 feet. Now that is how high up the wall that pole is leaning. Y'all see that? It's a pretty long pole because it's going to be longer than 22.4, isn't it? Yeah. All right. Flip to the back. We're going to talk about angle of elevation and angle of depression. Okay? So, your angle of elevation is when you are looking up at an object. So, like when little Jaden was flying her kite, she was probably looking up at that kite. Back in the last example, yeah, that was part of Davis's problem yesterday. He was looking at the string and not the kite. So anyway, so you're looking up at the kite. That's your angle of elevation. So you're looking up at an object, and it is formed by the observer's line of sight and a horizontal line. Okay, so your line of sight is how you're looking. And it's formed with that, and if the person is looking straight across. Okay, so I am 5 feet 8-ish, and so my eyes are down to about maybe 5'6" height. So that would be a horizontal line, me looking at 5'6" straight across, right? And if I looked up at the ceiling tiles, that would be my angle of elevation. The angle of depression, what do you think that is? When you're looking down, so if you're like standing on a mountain and you're looking down at the valley, okay? So you're looking down at the something. Like I would be looking down at my shoe. And the angle of depression is formed with the observer's line of sight, so how they're looking, and a horizontal line. Okay. So the cool thing about an angle of depression and how they're congruent to an angle of elevation, they are actually congruent to each other, those angles are, because of those horizontal lines. So you can kind of see in this picture, you have this boy that's looking up at a lighthouse, and horizontal from that lighthouse makes the angle of elevation. And then you got a lifeguard over here. If he was looking straight out, that would be the horizontal line and looking down. But do you see the swimmer down here? If swimmer looks up at the lifeguard, these angles right here would be congruent because of these two horizontal and horizontal make parallel lines, right? And these are alternate interior angles from each other. So angle of elevation and depression are congruent because they are alternate interior angles because of those horizontal lines.
the only thing we have left to tell is.
Okay, so the lifeguard's angle of depression is going to be same as the swimmer's angle of elevation because of these being alternate interior angles. Pretty cool, isn't it? I know. Okay, let's talk about number 5 right here. Let's talk about little girl Leah. She might be little. I don't know. I assume she is. She's going down a slide. Yeah. When you get too big, your slide don't fit, and your hips are too wide, you don't go down as easy. So maybe Leah's either really skinny or she is little. All right, Leah's mom is standing at the bottom of a slide at the playground, waiting for Leah to slide down. That makes me sound like Leah's a toddler, okay? So if the angle of depression from the slide, from the top of the slide to the bottom is 46 degrees. Okay, so here's Leah's mom. Here's Leah up top, right? Leah's up on top of the slide. Let's assume she has shoes on at the playground. She's got pigtails. Woohoo. There's Leah. Okay? Leah's mom is down here waiting to catch her. Let's have Leah's mom in a ponytail because she's got her daughter at the park. It's a hard day. Okay. There's mom. Here's Leah. Okay. And so Leah's mom's angle of elevation, she's looking at her daughter, right? All right. The angle of depression from the top of the slide to the bottom is 46 degrees. So Leah's angle of depression is right here, 46 degrees. So that means that's her mom's angle of elevation. Y'all see that? And there's the slide's height from the ground. Something like that. My pen's not working. All right. So the slide has a vertical height of 9 feet. So that's this height. Find the length of the slide. So what are we looking for? The hypotenuse. Very good. So do y'all see how like Leah's angle of depression is the same as her mom's angle of elevation? Y'all see that? Okay. So you can put the 46 degrees right here, but if you want to put it inside the triangle, it will be from her mom. So sine, cosine, or tangent? Well, is the 9, here's my angle, isn't it? Y'all see that? Okay, so what do you think? Sine, cosine, or tangent? Yeah, because I have opposite and hypotenuse. All right. So, sine. So we're going to say sine 46 degrees. Oh, come on, pen. I don't know what this thing is doing. Equals opposite over hypotenuse. So 9 over x. So we're trying to find the length of the slide, which is the hypotenuse. So how do I solve that for x? Multiply by x on both sides. And so x times the sine of 46 equals 9. Then what do? Divide by sine 46. So x equals 9 divided by the sine of 46 degrees. And then we'll get x by ourselves. We can use our calculators. 9 divided by sine of 46. Oops. I forgot my 6, didn't I? 46. Hit enter. Y'all getting about 12.5? 12.5 what? All right. So the length of the slide is approximately 12.5 feet long. Make sense? Y'all see what I mean? The mom's angle of elevation is the same as Leah's angle of depression. Y'all see that? Okay. All right. Here's another one. Casey sights the top of an 84-foot lighthouse at an angle of elevation of 58 degrees. So y'all, a lighthouse. I'm not good at drawing these things, but they're pretty cool. Let's just make this a striped lighthouse. Yes. So they got like a big old lookout tower, and then they got some kind of like thing with a light on it. Okay. Yay. So here's Casey. I'm gonna draw my triangle different this time. Here's Casey. All right, so he's looking up at the top of an 84-foot lighthouse. So the height of the lighthouse is 84 feet. And Casey's looking up to the top of it. Okay, this one's a little complicated because it tells me Casey is 6 feet tall. Aw. So do y'all see how this is a horizontal line right here? Right? And there's also he's standing on the ground, which is a horizontal line. Y'all see that? So this is my right angle down here. How far is he standing from the base of the lighthouse? So we're looking at this length down there. Y'all see that? Y'all see that? Okay. Well, I forgot my angle. 58 degrees. So he's looking up 58-degree angle. All right. So how do you think we can figure this out? Right. Because the only height from his angle of elevation is going to be just for this part of the triangle, isn't it? Not all the way to the ground. When he's 6 feet from the ground when he's looking up. We're saying that he's looking up, turns his eyeballs up. So we'll say his eyeballs are at 6 feet because they told us nothing different. All right. So what's this height then?
78.
78. Y'all see how we got that? We have to subtract off his height. Good. So, but isn't this distance and this distance going to be the same from where he's standing to where his eyeballs are?
As long as
Right. Yeah, as long as he's not doing this or this, right? Yeah, and I hope as long as that lighthouse is straight. All right. So, but y'all see where the 78 came from? The lighthouse is 84 feet tall, but he's 6 feet tall, so we have to subtract that off. So, what do y'all think we're going to use? Sine, cosine, or tangent? Tangent. So, we're going to say tangent of what? 58 degrees equals what? Yep, opposite over adjacent, so 78 over x. How do I solve for x? Multiply both sides by x to get out of the denominator. X times the tangent of 58 degrees equals 78. Then what? Divide by tangent of 58 degrees. So x equals 78 divided by, this stupid pen today. Go away. And now I got x by myself, so I can use my calculator. 78 divided by tangent of 58 degrees. That's not right. Is it right? It is right. 48.7. So x is approximately 48.7 feet from the base of the lighthouse. Very good. Very good. So let's do one more problem like that, can we? We're just going to do it all together. This one, they did draw the triangle. So this is what your test is kind of going to look like. There's one like this on your test. When is our test? Thursday. So it's coming quick. A survey is sitting on the balcony of an apartment 232 feet away from a clock tower. Using a clinometer, which is something surveyors use, the surveyor estimates that the top of the clock tower creates a 22-degree angle of elevation with the balcony at a point that is 24 feet above the ground. So they drew everything in this picture for us. Do y'all see that? All right. It says, to the nearest tenth of a foot, how high is the top of the clock tower above the ground. So we want to find this entire height of the clock tower. Do y'all see that? How can we do that? Game plan.
You can find the height of it that's above the balcony and that's one.
Very good. Because see, this 24 feet is the same as this 24 feet over here, right? Because we know those are two horizontal lines. So that's going to make a rectangle, right? So what we just need to do is find this height and add it with 24. Does that make sense? Okay. So how are we going to find that height? Sine, cosine, or tangent? Tangent, because this is opposite and this is adjacent from this angle. So tangent of 22 degrees equals what? Y over 232. So how do we get y? Multiply by 232. So 232 times tangent. Why is this only halfway writing everything? 22 degrees equals y. Calculator. 232 times tangent of 22. Or was it 32? 22. Equals about 93.7 feet for y. So 93.7 here. So how do I get the length of the whole height of the clock tower? Yeah. 93.7 plus 24. 117.7. I don't know what my thing is. And it's feet. Okay, so I think y'all have one similar to this on your test. Y'all think y'all could handle it on Thursday? All right, that is the end of notes for today. Trying to end them. There they